All right, let's get right into it. Today, we're tackling one of the biggest questions in system design: SQL or no SQL. I mean, picking the right database can literally make or break your entire application. So understanding the difference here is, well, it's everything.
And let's just start with this quote because it gets right to the heart of the matter. Look, this isn't about finding some single best database that beats all the others. It's all about understanding what you're giving up to get something else. The whole SQL versus no SQL debate is basically a masterclass in trade-offs.
So let's frame this with a big question. Imagine you're building the next big social app, the next huge online service. You're planning for millions of users, maybe even billions of clicks, posts, and messages. The choice you make right now on your database is going to decide if you scale beautifully or just crash and burn. The stakes couldn't be higher. First up, we've got the old guard, the tried and true veteran, SQL. You know, for decades, if you said database, this is what you meant. Think of it as the world's most organized, super reliable library for all your information.
The key word here really is structure. A SQL database is all about tables, rows, and columns. Before you can put anything in it, you have to define its schema. It's like a strict blueprint for your data. And that rigidity, well, it's SQL's greatest strength. And, as we're about to see, its biggest challenge. Let me paint you a picture. Think of an old school library card catalog. Everything has its perfect place. It's incredibly reliable. If you want to find all the books by one author, the system is built to do that flawlessly. That's SQL in a nutshell: structured, consistent, and amazing for connecting related pieces of data. But then, the internet happened, and suddenly we weren't just dealing with neat, tidy data anymore. Oh no. We had this explosion of messy, unstructured data coming from every direction, and we had to handle it at a scale nobody had ever dreamed of. This created a whole new kind of problem.
So this scaling challenge really led to two different ways of thinking. The old way was to scale vertically. You just make your one server bigger, faster, more powerful. It's like building a skyscraper taller and taller. But you can only build a skyscraper so high, right? The new idea was horizontal scaling. Instead of one giant server, you just add lots of smaller, cheaper ones. You spread out like a city growing wider. And for web scale stuff, that turned out to be way more flexible. And this is where NoSQL makes its grand entrance. NoSQL databases were basically born from this need for massive horizontal scale and the freedom to handle all the messy, unpredictable data of the modern internet. So what's the big deal with NoSQL? It all comes down to its lack of a rigid schema. It doesn't lock you into predefined tables. Instead, you can use flexible models like documents or simple key-value pairs. This gives you, the developer, just immense freedom and lets the database spread out across tons of machines with no problem.
So if SQL is a library, NoSQL is a giant warehouse full of filing cabinets. You can add new cabinets, new servers, forever. And each cabinet can hold totally different kinds of files, no master plan needed. It's incredibly scalable. But, and this is a big but, try finding related information that's spread across 10 different cabinets on opposite sides of the warehouse. Yeah, it gets complicated. That's the trade-off.
Okay, so that brings us to the heart of it all, the great trade-offs. Let's really put these two side by side and break down the fundamental choices you're making when you go with one over the other. This table really sums it up. For schema, SQL is rigid, NoSQL is flexible. For scaling, SQL typically goes vertical, NoSQL goes horizontal. Now, consistency, this one's huge. SQL gives you strong consistency, usually with something called ACID properties. Think of it as a promise that every transaction is all or nothing and the data is always correct. NoSQL, on the other hand, often goes for eventual consistency, or the principle called base. It basically says, hey, we'll prioritize staying online and everyone will catch up with the latest data eventually. And finally, querying. With SQL, it's the standard language everywhere. With NoSQL, it really depends on the specific database you're using.
Now, we can't possibly talk about these trade-offs without bringing up the famous CAP Theorem. It's like the law of physics for distributed systems. It says you get 3 guarantees to choose from, but you can only ever have 2 at the same time. First up is C for consistency. This is simple. Whenever you ask for data, you are guaranteed to get the absolute latest, most up-to-date version of it, period. It's what makes traditional databases feel so solid. Next is A for availability. This means the system is always online. It will always give you an answer. Now that answer might be a little stale, a little out of date, but it will never just fail on you. It's always available.
And finally, there's P for partition tolerance. This just means your system can survive the network failing between its different computers or nodes. And let's be real, in any big system, the network will fail. It's not an if, it's a when. So you have to design for P. You have no choice. And here's the punchline. Since you're stuck with partition tolerance, P, you're forced into a tough choice. Do you want consistency, C, or availability, A? Do you want a system that's always correct, but might go offline during a failure? That's a CP system, kind of like SQL. Or do you want a system that's always online, even if it means serving slightly old data sometimes? That's an AP system, which is the path many NoSQL databases take. All right, enough theory. Let's get practical. When should you actually reach for SQL, and when is NoSQL the right tool for the job?
You're going to want to stick with SQL when your data absolutely has to be perfect and interconnected. We're talking about financial systems, your bank balance, e-commerce orders, anything that needs that bulletproof ACID compliance. If the relationships between your data are key, SQL is your best friend.
And you'll lean towards NoSQL when you're just drowning in data, especially if it's unstructured stuff like social media posts, data from tons of IoT sensors, or real-time analytics. If your number one goal is pure, blazing fast speed at a massive scale, and you're okay with things being a tiny bit out of sync for a moment, NoSQL is where it's at.
But here's where things get really interesting. The lines are totally blurring. You might think, okay, SQL is for small stuff, NoSQL is for big stuff, but not so fast. Take Figma. They run their entire massive collaborative platform on a SQL database, Postgres, and they scaled it 100x. They proved that with smart engineering, SQL can absolutely hang at massive scale. And then on the complete other end of the spectrum, you've got Discord. They needed to store trillions with a T of messages. They went with NoSQL to achieve incredible performance at an almost unimaginable scale. It's just a perfect example of NoSQL doing what it does best, hyperscale.
So what's the real answer today? The truth is, it's not a fight anymore. It's not either or. The best, most modern systems often use both. You might use a SQL database for your critical user accounts and billing, and then a NoSQL database for something like activity feeds or chat logs, all within the same application. It's really about using the right tool for the right job.
And that brings us right back to where we started. It all comes down to trade-offs. There's no magic bullet, no one-size-fits-all answer. There is only understanding what you need for structure, for scale, for consistency, and making a smart choice. So, for your next big project, what trade-offs are you going to make? Thanks for watching.